Alright, this video is on prime and composite. So first of all, what is a prime number? So a prime number is a number only divisible by two other numbers. So it only has two factors, okay? So it's a number with only and exactly two factors. Remember, factors are numbers that divide into it. We'll talk about that in a minute. So an example would be the number 3. Sorry, I'm jumping ahead. Its only factors are 1 and 3. Only 1 and 3 divide into it. Another example would be 7. It's only divisible by 1 and 7. Or 2. It's only divisible by 1 and 2. 2 is actually a special one. It's the only even one. Okay? And it's actually the lowest also. Because 1 is actually not prime. People make that mistake sometimes. But it only has one factor. And for to be prime, it has to have two factors, okay? 1's only factor is 1, okay? You notice the factors tend to be, well, not tend to be, they are 1 in itself. And since 1 is itself, that's why it only has one factor. Composite numbers are numbers with more than two factors, so 3 or more. Numbers with 3 or more factors. So really any even number other than 2 is going to be composite because it's going to have 2 as a factor, right? 4's factors are 1 and 4 and then 2. If you did 8, you have 1 and 8 and you have 2 and 4. So as long as there's at least one other factor other than 1 in itself, that makes it composite. So again, 1's not either prime or composite. So we're really talking about starting at the number 2. And 2 is our first prime number and our only even one. All right, so what I want you to do is you're going to pause. You're going to write down all these numbers, and next to it, you're going to write down whether you think they're prime or composite. So remember, you're trying to figure out, are there other numbers other than 1 in itself that can divide into them? So go ahead and hit pause and then hit play to check your answers. All right, number 9 is our first one. It is composite because it's divisible by 1 and 9, obviously, but it's also divisible by 3. 85, again, composite. Remember, use your divisibility rules to figure this stuff out. If it ends in a 5, that means it's divisible by 5, okay? 13, prime, only divisible by 1 and 13. 183, actually composite. That's a tricky one. It kind of looks like it might be prime, right? Use your divisibility rules. If I were to add these numbers up, I would get 12. Remember, 12, well, that means it's divisible by 3 because 12 is divisible by 3. So that's composite. 27, also composite. It's divisible by 3 and 9. 3 times 9 is 27. And 99, also composite. Anytime you have a double number like that, it's divisible by 11, right? 9 times 11 is 99. Okay, so our only prime one up there was 13. All the rest had at least one other factor, if not more, that we didn't mention. All right, so we mentioned factors a couple times, right? Factors is a number that divides in evenly. And you're going to have a finite number of factors, which means that it's not going on forever. So if we're talking about the number 10, its factors are 1 and 10, 2, and 5. Okay, so it has 4 factors. Prime factorization is the way to write the factorization of a number using its prime factors. Okay, and I'll show you our method to use that. So we're going to use a factor tree, and they call it a tree. Kind of ends up looking like a Christmas tree, like a pine tree. So you're making little branches, and the two numbers coming off the branch have to multiply. Make sure you're multiply to equal the number above it. So obviously there's more than one option. I use my divisibility rules, and I see 6 and 10 is pretty obvious. Whenever it ends in a 0, I like to use 10. You could have done 2 and 30, that's fine. 4 and 15, you'll get the same answer no matter which ones you do, as long as they multiply to equal the number above it, okay? So use 6 and 10. Then you look and you see, okay, well, 6 prime? No. Then I keep going. 2 times 3 equals 6. Now I look, is 2 prime? Yes. Is 3 prime? Yes. So you circle them. So whenever you get to a prime number, circle them. Then go over here. 10 is also not prime, so you can do 2 times 5. And now both of those numbers are prime. All right, so the prime factorization of this would just be these numbers written as multiplication together. 2 times 2 times 3 times 5. And you put them in order from least to greatest like that, okay? Now, you can also use exponents to write it out as well. Where we would use the exponents is this 2 times 2. Remember, when you have a number repeating, multiplying by itself, you can write it using exponents. So that would be 2 squared, right? 2 times 2 is 2 squared. Times 3 times 5. Those ones I can't use exponents because they weren't repeated. I could put a little 1, but that's kind of pointless. If you want to check your work, all you have to do is multiply this together. 2 times 2 is 4, times 3 is 12, times 5 equals 60, which is the number we're representing with this prime factorization. So that means we're correct. Yay! Okay, so that's prime factorization. So I want you to go ahead and pause it. I want you to work out all 4 of these prime factorizations. If you can use exponents, do it, great. And then hit play to check your work. All right, so let's start with the first one, 123. So remember my trick of using the divisibility rules. It's not even, so I can't divide it by 2, but these do add up to 6. So that means it's divisible by 3. So I get 3 and 41. 41 is actually a prime number, so at this point I'm done. So the prime factorization of this is just 3 times 41. And sometimes that'll happen. It feels like a weird prime factorization having 41 in there. But as long as all the numbers are prime, that's it. All right, next one, 45. Do 5 and 9, and 3 and 3. So now these are all prime. So if I'm going to use exponents to write this, I need to do 3 squared, because there's 2 3s, times 5. Remember, you can check yourself. 3 squared is 9. 9 times 5, 45. And all those numbers are prime. So that's my prime factorization of that. 99, I'm going to do 9 and 11. And 9 is 3 and 3. 11 is prime, so that's done. So if I'm going to use exponents, I would write 3 squared, because there's 2 3s, times 11. 3 and 11 are both prime, so that's good. 3 squared is 9. 9 times 11 is 99, so that's the right answer there. And finally 100, I'm going to do 10 and 10. So that's going to 2 and 5, 2 and 5. So again, if I'm using exponents, there's 2 2s times 2 5s. And 2 and 5 are both prime. If I do 5 squared, I get 25. 2 squared is